In this video, I'm going to talk about sigma and pi bonds. So, in the last couple of videos, when I talked about hybridization and Lewis structures, I mentioned single bonds, double bonds, and triple bonds. But I never really got to talk about how they look when we're talking about orbitals. So I wanted to make a video on what are called sigma and pi bonds. And well, as you may recall from when I was talking about the four different orbitals, S, P, D, and F, those four orbitals are wave functions. And with waves, there's two types of interactions. So let's say we have one s orbital here, another s orbital here. Actually, I'm not going to put the plus. And then this will form something. And because there's two interactions, I'm going to do the same twice. So this will form something else. So the first type of interaction between them is when you add them. So I'm going to say add. And what that will yield is a big orbital. So pretty much they just fuse together. And that's what we call bonding. Bonding. That's our first interaction. The second interaction is, well, just subtraction. I'm going to write sub, and that will just divide it into two different things. So one red, one blue. Just like a plane of difference. And that's what we call a node. So there's a node between them. So I'm going to break it apart. I'm going to talk about each separate. So we said we have two, and we added them to form a big one. And this is called constructive interference. And the result of the addition of the constructive interference is what's called bonding, a bonding molecular orbital. Which is also called a sigma bond. Which is represented with the sigma sign. So it's not the best drawing. It looks something like that. And well, this is basically what happens when two atoms bond. We have a carbon here and a carbon here. When you add them, when they constructively interfere, they form a bigger chain, and that's a sigma bond. This is there's a sigma bond keeping them together. And bonding is very stable. So let's talk about our the other interaction we had. So we had the two s orbitals. We subtracted them. And we formed a node between them. So we have a node, and this is what's called destructive interference. Sorry. Destructive interference. And we call this a node, but the formal name is antibonding molecular orbital. And we just represent that with the sigma sign with a star. And what I was talking about stability before, I meant that bonding is more stable. Bonding means stable, pretty much. It's more stable than anti-bonding because it's lower in energy. So let's talk about sigma bonds, or just bonds, our normal bonding. There's basically three things you have to know about them. They are cylindrical, and by that I mean the symmetry. I'll put up a drawing shortly. They possess free rotation. And they're present in all bonds. So what I mean by present in all bonds is that a single bond, a double bond, and a triple bond have sigma bonds. Each of these has one sigma bond. So a single bond is just a sigma bond by itself. A double bond is a sigma bond and a pi bond, and a triple bond is a sigma bond and two pi bonds. And I will talk about pi bonds after I finish sigma bonds. So I said I would put up a picture. So this is how a sigma bonds looks like. So you can see it's fused. Is what I drew before. We had one thing here, one thing here. When you added them, it made a bigger thing. So that's the pre-drawing of it, pretty much. And the way you could just think of this is you had a carbon here and a carbon here, and then they were together. So this is they were bonded. This is one carbon, this is the other carbon, and this is the sigma bond. So it's cylindrical, as you can see. This is it's cylindrical in shape. And the other factor I mentioned is that it has free rotation. When you're drawing a molecule, you don't draw it like this. This is just an easy way to look at it. The actual shape of the molecule will be something like this. In each of these is a carbon. There's a carbon here, a carbon here, and a carbon here. And a sigma bond, because it has free rotation, it means that this will be the same as, let's say, this. It doesn't, like, you can rotate each molecule. Like, instead of having this carbon in this shape, you could just rotate it down, and because it's a sigma bond by itself, it will rotate with no problem, and the bond will not break. And that's what I mean by free rotation. You'll understand the logic of this better when you start taking organic chemistry. I just want to give you a good background to it. And well, that's just sigma bonds. Let's talk about pi bonds now. And well, a pi bond looks somehow different than what a sigma bonds look like. this is how a pi bond looks like instead of what our sigma bond was. So there we have both pictures. You can see that in the sigma bond there's no fusing between the two molecules, the two atoms. There's just like there's no overlapping between them. They're just parallel to each other. It's like two sticks. And the difference between the pi bond and a sigma bond is that a pi bond does not have free rotation, so it has restricted rotation. And it is just present in double and triple bonds. So as I said before, sigma bonds have free rotation. You can rotate them with no problem. And just thinking about the example I said, with this, and this, just like, just flip it around, like that. That doesn't really matter for now, but when you try and flip a pi bond, let's say you want to flip, let's call this molecule A and molecule B. Let's say you try to flip molecule B, you will have molecule A stay the same, and molecule B will be like this pretty much. So if one is vertical, the other one is horizontal. It's really hard to draw it like that here, but the bond would break. It's like it's coming out. So that's what I meant with free rotation. If you try to rotate it, the bond will not stay stable, so it will just break. And just to finish up, I'll talk briefly about double and triple bonds. This is how our double bond looks like. So it has one sigma bond and one pi bond. So as you can see in the drawing, this is the sigma bond. There's fusing between them, so like this, and this is our pi bond. This green thing. They're kind of parallel to each other, but there's a little bit of electron density there. If you don't understand this drawing, it's just a carbon, hydrogen, hydrogen, a carbon, hydrogen, hydrogen, and we have a double bond there. And one of these bonds is going to be sigma bond, and the other one is going to be a pi bond. And finally, triple bonds. They have one sigma bond. Remember, everything has one sigma bond and two pi bonds. And well, it's just pretty much the same drawing. We have a carbon with a triple bond there, a hydrogen on each side, and well, this is just this, and these two are the two pi bonds. The other doesn't matter, but you can see here that the purple is one pi bond, the blue here is another pi bond, and then the yellow is our sigma bond. And well, that's all I wanted to cover. I'll go into more detail when you get into organic chemistry. And well, if you found the video helpful, like it and share it with your friends.